What's up, mobile devs? Today we are going to build from scratch this powerful bottom sheet animation in React Native by using just the reanimated and the gesture handler package. This video is part of a YouTube series called What About Gestures, related to React Native animations that heavily depends on gestures. So if you like this kind of content, don't forget to subscribe to the channel to be updated on my upcoming videos. Before moving on, I sincerely want to thank Yael, Pavel and someone. A few months ago, I opened a Buy Me a Coffee account without any expectations, and out of nowhere I received support from them for my YouTube content. So thank you very much for your support. That said, we can finally move on the code part. Here I've created a React Native project with the Expo CLI, and I'm using of course the TypeScript configuration. In this project I've also included the gesture handler package and the reanimated package, both with the version above the 2.0 version. And inside the bubble config.js I've added of course the reanimated plugin in order to complete the reanimated installation process. So that said, we can start to update a little bit this UI. So let's use a dark background color, and let's update this status bar with a style equal to light. So right here in this project we are going to use of course the gesture detector. So we are going to implement the pan gesture, and in order to enable the pan gesture we need to wrap all the app with the gesture handler root view component. So this component is from the React Native gesture handler package. So here let's specify flex1, and here we go. So nothing is changing, but keep in mind that without this component the pan gesture will not work, especially on Android. So that said, we are going to place here the bottom sheet component, and this component needs to be created. So we are going to create this component inside this components folder. So let's say bottom sheet tsx, and inside this file we are going to use the React Native snippets, and we are going to declare our bottom sheet component. So let's import it. So we need to import it from components bottom sheet file, and here we go. So it is right here. So of course we need to fix a little bit the UI. So for now we are just going to use a simple view, and we are going to define here the styles.bottomSheet container. So let's access inside the style the bottom sheet container, and we are going to define a height equal to 500, a width equal to 100%, and a background color equal to white. So here it is. So I believe that something is wrong. So we need to place this bottom sheet inside this container style. So here it is. So this component of course needs to have the same height of the screen. So we need to access the screen height, and in order to access it we need to use the dimensions API from React Native. So let's use dimensions, and let's specify here get window. So we are going to retrieve the height, and we are going to name it screen height. So we need to assign this screen height to the bottom sheet container height, and here we go. So right now, of course, we need to fix the position of this bottom sheet container, and in order to do it, let's say position equal to absolute, with top equal to screen height. So we are basically pushing down this bottom sheet right here. In fact, so if we check screen height divided by 1.5, we can see that it is right here, so 1.2, and with the screen height divided by 1, the bottom sheet will be right here. So for simplicity, for now, let's just set the top equal to screen height divided by 1.5, and we are going to fix it in a while. Let's also include the border radius parameter equal to 25. So here it is. And the last UI feature that we need to implement is this simple gray line that we have usually right here. So let's define here the styles.line. And let's say width equal to 75, height equal to 4, background color equal to gray. So here it is. We need to center it. So let's say align self equal to center and margin vertical equal to 15. So let's also include some border radius. So let's say border radius equal to 2. And here it is. So finally, we can start to deal with the pan gesture. In order to deal with the pan gesture, we are going to use the gesture detector component. So let's import gesture detector from React Native gesture handler. And let's wrap this BottomSheet container. So in order to handle the gesture detector, we always need to wrap an animated view. So let's fix it right here. And we need to import animated from React Native reanimated. So we need also to assign to the gesture detector the gesture parameter. So let's define here the gesture equal to gesture.pan. So here gesture is just imported from a React Native gesture handler. So we need to handle some callbacks. For now, we are just going to handle the onUpdate callback. And let's try to access the event.translationY. So here something is missing. No, actually everything is working nicely. So we can see here that we are able to visualize the event.translationY. So the main goal right now is to store this translation Y inside a shared value and to pass the shared value to this animated view in order to translate on the vertical axis this BottomSheet. So let's define here the translate Y shared value. And let's store the event.translationY inside this translate Y value. So in order to pass this translate Y value to this animated view, we are going to use, create a reanimated BottomSheet style by using the useAnimatedStyle hook. And we are just going to return a style that uses transforms. And we are going to assign to the translate Y shared value. So let's pass this reanimated BottomSheet style right here. And let's reload. So here we can see that everything is working perfectly. So of course, if you're not familiar with this kind of concepts, so shared value, the use animated style, and so on and so forth, feel free to check out my other series called Animate with Reanimated. I will put, of course, the link in the video description. So that said, we can see that everything seems to work perfectly. But you probably know that by start to dragging a second time, we can see that there is, of course, an issue. And this issue is related to the context. So basically, we need to store the previous position inside an object. And we need to account in this onUpdate callback the previous translate Y position. Otherwise, the animation will always restart from the beginning. So in order to do it, we need to define the context object. So the context object will be a shared value. We are just going to handle the Y-axis. And we are going to store on the onStart callback inside the context.value the previous translate Y value. And we are going to consider in the onUpdate callback the context.value.y. So the previous position. So If you're not familiar also with this context object, I've talked about this shared value, this technique in my previous video related to the what about gestures series. I will of course put it in the video description if you're interested. So if we reload, we can see that everything is working perfectly. So there is of course an issue. So if you continue to start the drag behavior, you can see that we are able to scroll a lot, and that's not fine. We need of course to clamp this view, and we need to set a max translate y value. So first of all, let's try to fix here the let's actually try to log the translate y value, and we can see that when we scroll till the top of the screen, the translate y value is negative. So we want to set a minimum value by using the mat min function equal to translate value and the max translate y value. So let's actually say for now screen height minus screen height since it is negative, and let's reload. So here there is a mistake. So actually let's say max, and we can see that everything seems to work fine, but it isn't. And that's because we are starting not from, in this position translate y is equal to 0. So we are able to scroll from this position to screen height. So in order to fix this behavior, we need to remove here screen height divided by 1.5. So the translate y will be right here. So the translate y will be equal to 0 in this position, and we are going to be able to scroll until the screen height. But of course, we need to push up this bottom sheet, and in order to do it, let's just use the use effect, and let's fix here translate y value equal to let's say screen height divided by 3. Minus screen height divided by 3. So here let's also use with timing. And here we go. So at this point the translate y is at this point is equal to minus screen height divided by 3. And if we scroll, we are able to see that the clamping is working fine. So I hope that this was clear. Basically, in this position, so in this condition, the translate y value previously was equal to 0. In this condition, instead, with the use effect hook, it is equal to minus screen height divided by 3. So the clamping is working perfectly, since we are accounting the minus screen height divided by 3 to the translate y value at the beginning of the animation. So let's just fix this with timing function. So you can see that it is working perfectly, but I think it is much more interesting, the spring animation, for this context. So let's also update the configuration. We are going to use a damping equal to 50, just to reduce a little bit the bounce effect. And here we go. So of course, the clamp function is working finely, so the matmax function is working perfectly, but we want to reduce a little bit the max translate y value. So let's say plus 50, and let's reload, and we can see that everything is working. So let's save this value inside a constant, and this constant will be called max translate y. So let's save it, and let's say max translate y equal to minus screen height plus 50. So another step that it is interesting to handle is related to this border radius. So in this animation we can see that the border radius is fixed to 25, So here we have set the border radius equal to 25, but it is actually interesting to update this border radius based on the translate y value. So for instance, let's say that we want to set in this condition, so when the translate y reaches the max translate y value, we want to set the border radius equal to 5 with a smooth animation. So in order to achieve this behavior, we can just use the interpolate function from reanimated. So let's define here border radius equal to interpolate. We are going to use interpolate from reanimated, and we are going to pass the translate y value. So here we need to set the input range, the output range. So I will just write the input range and the output range, and I will explain you why it is working. So let's set here border radius equal to 25 and 5, and here let's set max translate y plus 50 and max translate y. Let's assign the border radius to the reanimated style, and let's set extrapolate.clamp. So let's reload, and we can see that everything is working nicely. But why it is working? So basically what we are saying with this interpolate function, we are saying that when the translate y value reaches the value max translate y plus 50, the border radius needs to be equal to 25. Otherwise, when the translate y reaches the value max translate y, so this one, the border radius needs to be equal to 5. So if the translate y value is a value between these two values, the border radius should be nicely interpolated between 25 and 5. So the latest thing is of course this extrapolate clamp. And basically with this extrapolate clamp we are saying that if the translate y value is less than max translate y plus 50, the border radius needs to be equal to 25. Otherwise, it will be automatically interpolated to a value that is greater than 25. So for instance, if I comment this extrapolate clamp, you can see what is the behavior, and it isn't fine at all. So I hope that this interpolate explanation was clear, but I've done other tutorials with this interpolate function, so feel free to check out my previous tutorial related to this topic. So that said, we need to handle in the end the on-end callback. So in the on-end callback, we need to check what is the current position of this BottomSheet. So for instance, if the current position is less than let's say screen height divided by 3, we want to animate back the BottomSheet to value 0. Otherwise, if the BottomSheet is positioned here, for instance, so is greater than the translate y position is greater than screen height divided by 2, we want to animate the BottomSheet to the max translate y. So let's see what I'm talking about. So here we need to handle the on-end callback, and let's check the translate y value. So if the translate y value is greater than minus screen height divided by 3, we want to animate the translate y value to value 0. So of course with the spring animation. So let's say with spring 0. So let's reload, and we can see that it is working perfectly. Otherwise, if translate y value is greater than screen height divided by 2, actually if it's less than screen height divided by 2, we want to animate till value max translate y. So let's see. So here we are between screen height divided by 3 and screen height divided by 2, and we don't want to do nothing. And here we are above screen height divided by 2, and we can see that the animation is working perfectly. So for instance, I think that is quite better to use 1 divided by 5. So here it isn't animating, and at this point it will animate. So as you can see, we are using this with spring function with this kind of configuration a lot of time. So of course we can refactor a little bit this code by creating the scroll to function and by using the use callback hook from React. So here we are going to copy this code. We are going to set a destination. Let's say destination of type number, and let's assign here destination to with spring. So we are going to replace here scroll to value 0, here scroll to value max translate y, and here let's say scroll to minus screen height divided by 3. So we can see that everything is not working, I hope. So everything is not working. And that's because we are missing the worklet keyword inside the scroll to function. So we can see that we are trying to call synchronously a function that is a JavaScript function. So we can solve this problem, with this issue, with two different solutions. The first solution is to mark the function as a worklet, and the second solution is to execute the scroll to function with the run on JS method from reanimated. So in our case, it is much more easy to use the worklet keyword right here. So let's see what's going on. And we can see that everything is working perfectly. So I believe that at this point the missing step is to implement the button that is on the screen. And probably this is the most interesting part of this tutorial. So first of all, let's try to define here a button. Let's just use the touchable opacity. So we are going to use touchable opacity from React Native. And let's implement here actually the style with styles equal to styles.button. So we are going to set an height equal to 60, aspect ratio equal to 1, background color equal to white. So here it is. Actually, let's say height equal to 50, and the border radius equal to 25, with an opacity equal to 0.6. So here it is. So here, let's create the onPress callback. So let's use callback from React, and let's assign this onPress callback to the touchable opacity. So the main goal right now is to access the scroll to method from the BottomSheet from the onPress callback. So the interesting part is that we are going to create a reference. We are going to bind this reference to this BottomSheet, and we are going to bind the scroll to method to the BottomSheet reference. So first step is to define here the reference with the use ref hook. So let's import use ref from React, and we are going to bind the ref function, the ref object to the BottomSheet. So ref, here it is. So the purpose will be to call ref.current scroll to, and let's say minus 100. So in order to implement this behavior, we need to update and to refactor a little bit the BottomSheet. Basically, in order to use the reference outside, we need to implement the BottomSheet as a React forward ref component. So here let's wrap all the component with React forward ref, and the React forward ref component will have here the properties and here the reference. So just to be precise, we are going to define the BottomSheet props, and we are going to define the BottomSheet ref props. So the ref will have the scroll to method, So let's say here destination of type number and return type void. And we are going to specify here the BottomSheet ref props and the BottomSheet props. So this is of course just for TypeScript. So here we are just saying that the reference has a property as a function that is called scrollTo. The final step is just to bind this scrollTo method that we have defined right here to this reference. And in order to do it, we are going to use, in my opinion, the most underrated hook from React that is called useImperativeHandle. So let's import it. And this hook takes as the initial parameter the reference. And the second parameter is just a function that returns the BottomSheet reference properties. So here we are just going to return the scrollTo method inside an object. So the third argument is just the dependencies, and we need to pass the scrollTo method. So in my case, I'm using Expo and I haven't the ESLint configuration active, so probably in your case you will see here a warning and you need to pass the scrollTo method. So here let's export the BottomSheet ref properties, and we can declare here the reference with the useRef of type BottomSheet ref props. And we can see that we haven't the warning anymore. So let's reload. Let's tap here, and we can see that the onPress function is working perfectly. So we can get rid finally of this use effect. And we can say, for instance, here -200. So here it is. So at this point we are almost done. The final step is just to handle the toggle behavior. So for instance, what do we want to do? We want to handle if the BottomSheet is active, and if it is active, we want to toggle it back to, we want to scroll back the BottomSheet to value 0. Otherwise, if it isn't active, we want to scroll the BottomSheet to value -200. So here it would be nice to access the isActive parameter by calling ref.currentIsActive. And of course, here we need to implement this isActive function. So as before, we need to add here the isActive function to the BottomSheet ref properties. And let's just return a boolean. So we need to define the isActive function with the useCallback. And for now we are just going to return true. Let's pass here isActive, and let's pass it right here. So how can we know if the component is active? First of all, we can create a shared value with the initial value equal to false, and we can we know that all the BottomSheet transition will pass from this scrollTo method. Therefore, here we can check the destination parameter, and we know that if the destination parameter is equal to 0, active should be false. Otherwise, active should be true. So basically, if the destination parameter is set to 0, we are just toggling back the BottomSheet to value 0 to the bottom of the screen. Otherwise, the BottomSheet will be on every other position of the screen, and it will be, of course, active. So we can refactor a little bit this condition. So we can just write active value equal to destination different from 0. And here we go. And inside this isActive function, we can just return active.value. So here, finally, we can access if it is active or if it isn't. And if it is active, we want to scroll back to value 0. Otherwise, we want to keep the scroll to -200. So let's reload. And we can see that this animation is working perfectly. So I think that right now we are almost done. An interesting part is that, of course, inside this bottom sheet component, you would like to pass any kind of item. So for instance, here, let's say that you want to pass a view with the style equal to flex1, and let's say background color equal to orange. So in order to implement this functionality, here we need to pass, we need to define the bottom sheet props. We need to specify here the children property of type React node. So let's access the children property right here, since here we have the bottom sheet props. And let's call, let's retrieve, let's pass here the children. So after the gray line. And I believe that everything is working perfectly. So the animation is completed. Let me know in the comments if you liked this video. Let me know if you have any kind of other ideas for my future videos. And of course, leave a like and subscribe to the channel if you like this kind of content. So thanks a lot, really thanks a lot for staying with me all this time.